Y'all, and welcome to our last unit together. It is so sad. We have finally reached the end. We are talking about vectors. Y'all, just some quick housekeeping. We do have about 3 weeks left of school. Not about, we have about 3 weeks. We have 3 weeks left of school. And our last week is going to be our final. I'll have some details on that, so just make sure you're checking your Canvas front page and the like. So y'all, let's go ahead and dive right into the wonderful world of vectors. I don't know if you're familiar with the movie Despicable Me, but if you have seen it, perhaps you will remember there is a supervillain on there who goes by the name of Vector. And he actually, I'm not even lying, he actually defines vector in the mathematical sense and does a pretty dang good job of it. So we're going to use his very same definition. So a vector is a quantity representing both direction. Actually, let's put that in all caps because this is important. Direction and magnitude, exclamation point, because we're super excited about it. And obviously I'm going to put those words in a different color because they need to be, you know, popping. And so apparently does the bottom of the exclamation point. So a quantity representing both direction and magnitude, right? Oh yeah, that's what he does on the movie. It's a fun movie. You guys should watch it. It's great. So a couple of things about this. A vector on a graph is represented by an arrow, right? It looks like this. Now to those geometrically minded among you, if you remember geometry, this looks a lot like a ray, not a Lindsay ray, although that's cool too, but a ray, R-A-Y, which is just a point with a line extending in one direction, right? So that's basically what a vector is. The exception with a vector is that with a vector, the arrow here does not mean that I'm going on forever. The length of a vector tells you the magnitude, how strong it is, how far we're going, how much force is being applied, right? So if I had this vector right here, and then I had this vector right here, they're not both going on forever, right? The arrow is not going on forever. That's not what that means. It means that this vector is stronger than this vector, or it's going farther, or it's applying more force, whatever that vector is representing, right? So be careful with the arrows. The length is very finite, even though there is an arrow, so it's a little deceiving. Let's do some quick vocabulary while we have this vector. So this little guy right here, that is called the initial point. Initial for like initiate, like the beginning, right? And then the tip of the arrow is called the terminal point, like when you land in a plane at a terminal, that's the end of your destination, right? So we have the initial point, we have the terminal point, and the distance between those two represents the magnitude, right? So I can say this is like the length of the arrow, right? That represents how strong, just like I said before. So if it's a shorter length, less strong, a longer length, more strong. Sorry, my wife is all like, can I come in? Because she wants to come in this door. I don't know if she's going to come in. We'll see what happens. Now the direction, y'all, we are going to represent by way of an angle. And this is going to be an angle just like on the unit circle from standard position, right? And we're going to talk more about this here in just a moment. So if I assume that this was on the positive x-axis, the direction angle would be right here, and I'm just going to call that theta. So that is the direction angle. So that tells us which direction we're headed in, right? So those are the two things that I need to know about vectors. The magnitude, the length between the initial point and the terminal point, and the angle, how far we're moving up or down, which direction we're going into. Now, the notation for writing vectors, let me go through this real quick. The notation for writing vectors, if this was like A and then B, this would be vector A, B. Sometimes there's an arrow over it, sometimes there's not. But I want you to know that AB, vector AB, is not the same as BA. Okay, those two are not equal to each other. If you put the letters backwards, you're going to be headed in the opposite direction, which is going to be, well, bad. So don't do that. So initial point is the first letter. Let's do some highlighting. Initial point is the first letter. Ding. And then, let's see screen. The terminal point is the second letter. So just make sure you keep that condition because it is very, very important. Okay, so that is the definition, and I think all of the vocabulary that we're going to need for vectors. So y'all, let's go ahead and talk about how we describe vectors when they are sitting on a coordinate plane. So I am going to go ahead and just draw a quick little quadrant 1 right here. Let's make our vector purple. So we're going to start it here at the origin, and it's just going to be going up. So this vector is in standard position. And as a reminder, I think I'm going to go ahead and write this out. Standard position just means that the initial point is at the origin, right? So we are going to have some vectors that are not on standard position, but when you describe the magnitude and the direction of them, I'm going to want you to assume that we have moved them to standard position, so we can talk about their magnitude and direction from there. So in standard position, you will have the angle theta, which we call the direction angle. Ooh, let me make that a little less bold. The direction angle, and what you'll have here, y'all, is the ordered pair at the terminal point. So right here where it ends, right there where it ends, you're going to have an ordered pair. So say this length right here was x, and this length right here, make that a little bit better, this length right here was y, then the ordered pair right there is going to be xy, right? Now for a vector, what we would write it as, to differentiate it from an ordered pair, we would write it as x comma y in these little pointy brackets, like that. So that's how you know it's a vector. It's not just a regular line. It's not just a line segment. It is, in fact, something that requires us to record both direction and magnitude. Okay, so when a vector is at standard position, you represent the position by x, y, voila. Okay, questions? If you're raising, I don't know, if you're raising, send me an email, y'all. Okay, so I want to do a couple of examples. And you know, y'all, the good thing about this unit is that we are not learning anything new. As far as like the math, we're learning some new vocabulary and stuff like that. But as far as the math goes, we're just using some good old right triangle trigonometry, right triangle calculation. So like the Pythagorean theorem, SOHCAHTOA, that's really it. So we're taking all of our fun old skills and using them in a new context. But it's nice because we're not learning anything. Excuse me. Okay, so let's say let's do something different. Let's say the vector, we'll just say AB, is boop, 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 like that. What I want you to do is find the direction and magnitude. Y'all, hey, my partner's trying to get in. Hang on. Okay, I'm back. Okay, so what I want you to do, I actually want you to pause this video and see if you can figure out this by yourself. Like, see if you can use what I just showed you up here, what this means, and see if you can figure out what is the direction angle and what is the magnitude of that vector. So pause and then come back and check your answer with me. Pause now. Did you pause? I can't even, I don't know. Okay, so I'm gonna walk through this real quick. And 4, 7. So I'm gonna put my vector in purple. So let's go 1, 2, 3, 4 over, and 1, 2, 3, 4, 5, 6, 7. So that is a lovely representation of my vector. And it is vector AB, so I'll go ahead and label it right there. Okay, so let's start with a magnitude. The magnitude is going to be very, very easy. So what I know is that this length right here, the x value, is 4. And then what I know up here is that the y value is 7, right? So those guys make a right triangle. So what we can use is, oh my God, our good friend, the Pythagorean theorem, to find the magnitude, because it's just the length. The magnitude is just the length. So let's do that real quick. A squared plus B squared equals C squared. Email. So oopsie, let's do 4 squared plus 7 squared equals C squared. That's 16 plus 49 equals C squared. 16 plus 49 is 65. Let's make sure I have that right, since I'm not in class. So y'all can't correct me if I've got this horribly wrong. It is 65, hot dog, equals C squared. So that means rad 65 equals C. Okay, so this is the magnitude, right? So there is a way that we write magnitude. There's a notation for magnitude. So what I would say, it's the vector AB. And so for the magnitude of vector AB, we put these like double absolute value looking stuff on it. So that means, the magnitude of the vector AB, A to B, is rad 65. We do want to keep it positive. I know in best practice for mathematics, when you take a square root, you do have positive and negative values. However, for this, since we're looking for the length, we're looking for the like how big the force is, we're going to keep it as a positive number. So don't worry about the negative. Okay, now let's look for the direction angle. So I'm going to draw in our little direction angle right here. There's a little angle theta. Hi. So we need to find that direction angle. Now here's the deal, y'all. We have a right triangle. You just did a whole unit on working with non-right triangles and finding missing angles and sides, but this is a right triangle. So we don't have to even use a law of sines or law of cosines. This is going to be a throwback to our days of SOHCAHTOA, right? That's all we got to do. So from the angle theta, I have 7, which is the opposite side, and I have 4, which is the adjacent side. So which one, sine, cosine, or tangent, which one of those am I going to be using for opposite and adjacent? I can hear you saying tangent, and you are, in fact, correct. So what I can say is that tangent of theta is equal to the opposite over the adjacent. So that means the tangent of theta is equal to 7 over 4. So what I'm going to do is take the inverse tangent of 7 over 4. I want these to be in degrees. Most of the time, vectors are used for navigational purposes. So like if you're an airline pilot or you're a ship navigator, ship captain, something like that, and you're going to be looking on a compass, and compasses come in degrees, so you want to use degrees. The other time that vectors show up a lot is in physics in engineering where you're talking about forces. So like you have a brick and gravity is pulling on the brick, and then you come along and try to push the brick. And so you have a force going this way and a force going this way. And you want to see like, what's the resulting force? Like, which way are we going? And those are usually in degrees. So let's stay in degrees for this unit. Make sure your calculator is in degrees for this unit. It's going to make everything better. So let me just make sure I am in degrees. I am. And I'm going to say second tan of 7 divided by 4. And I got 60.26 degrees. Y'all, please, 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 please don't forget the degree symbol. There were a lot of y'all on the last test who left off the degree symbol on your angles when you were finding those. So please make sure. Our magnitude doesn't necessarily have units unless we're in a word problem and I'm like, hey, you're riding a bike and the X component is 4 kilometers per hour and Y component is 7 kilometers per hour. Then you would give me the magnitude in kilometers per hour. But since I didn't give you units there, you don't need them. But for angles, angles do have units because there's a very big difference between 60.26 degrees and 60.26 radians. So please, please, please make sure that you're not forgetting that good old degree symbol. So I am going to go ahead and just write this out. Direction angle is equal to 60.26 degrees. Yay. Huzzah. Vector. Okay, y'all, I am going to give you another example, and this time I really do want you to just pause the video and then come back. You can fast forward through me talking about how to do it. But I want you to check and make sure that you know how to do this. So here we go. Let's find the direction and magnitude of, let's call this, I'm going to give this a one letter name. I'm going to give it a lowercase u. And let's say that's 3, -2. So this is not in quadrant 1. So be careful because I want you to give me positive direction angles. I want all my direction angles to be positive, no negative direction angles. So see what you can do. Remember, I want you to pause this, come back, you can fast forward. So pause now. Did you pause? I hope you did. So I'm going to do this again. Like I said, feel free to fast forward if you would like. Let's do this, and I'm going to make my marks on every other one. There we go. Here's my vector. It's going to be at 3, -2. Oh, there we go. Okay, hooray. All right, so let's start. I guess let's just start with magnitude since that's going to be the easiest. So let me make my little triangle. So that was 3, that is 2. So I'm going to use a squared plus b squared equals c squared. 3 squared plus 2 squared equals c squared. So it's going to be 9 plus 4 equals c squared. 9 plus 4 is 13 equals c squared. So rad 3 equals c. So then I can say the magnitude of u is equal to rad, not 3, 13. Now again, y'all, you might be confused as like, why can you just name a vector u instead of like a, b or something? Good question. So if I don't know the endpoint names, what I can do is I can give the whole vector. I'm just gonna call that vector u. We usually use lowercase and they're like italicized. So if you see that, that's what that means. Okay, so we have found the magnitude. Hooray, let's find the direction angle. Now, I said that I wanted to keep the direction angle positive, which means if I did this, that would be negative. So I can't do that. So I need to find the positive version of that, which is that angle right there. Okay, so let's see what we've got. Here's my angle theta right here again. I have the opposite side. I have the adjacent side. So when I'm looking at SOHCAHTOA, y'all, adjacent and opposite, it's going to be tangent again. Here's a quick spoiler alert. It's pretty much always going to be tangent. Just so you know. Okay, So what I can say is that the tangent of theta is the opposite over adjacent, so that's 2 over 3. So then I know that the inverse tangent of 2 over 3 will equal theta. Again, make sure I'm in degrees. And I've got second tan, 2 divided by 3, and I have got 33.69 degrees equals theta. Delightful, so delightful. Okay, here's the problem. That 33.69 is this angle right here. How can I find this angle right here? We're just going to use some simple arithmetic, right? We know that all the way around the circle is 360 degrees, right? So we want 360 degrees except that little bit right there. So all I need to do is just say, hey, 360 degrees minus 33.69. And that is going to be 360 minus 33.69. That is going to get me to 326.31 degrees. So I can write that up here. My direction angle is 326.31 degrees. Excellent. Excellent. All right. Yeah. Hooray, look at us go. All right, so I am, hopefully you're feeling really good about that. You're feeling really good about Pythagorean theorem. You're feeling really good about finding the direction angle. What I am going to do is one more example with the, sorry, I'm trying to look for something. Here it is, okay. With the vector not in standard position, and I'm going to ask you to find the direction and magnitude, which means I have to kind of figure out, okay, if it was in standard position, what would be the direction and magnitude? So here we go. Example. Point A is at -3, 4. And point B is at 6, 7. Please find the direction and magnitude of vector AB. Okay, so it's getting a little dark in here. Okay, so what we want to do now is I'm going to draw this so we can visualize what we're actually working with here, right? So let's get, actually, I'm not going to be able to do that. Let me speed it over a little bit. Yeah, so -3, 4, and 6, 7. Cool. So let's go ahead and put point A and B on our little graph here. So A is at -3, 4, so 1, 2, 3, 1, 2, 3, 4 right there, that's point A. B is at 6, 7, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. B is right there. And it says the vector AB, so that means A is the initial point, B is the terminal point. So I'm starting at A, and then my arrow will be at B. So I want to know the direction and magnitude of this. So let's go ahead and start with the magnitude. So y'all, I don't know if you remember, way back in, well, definitely in AGS 1, I think also in AGS 2, not sure about AGS 3, you use something called the distance formula, right? And basically that just means I'm trying to create a right triangle on this graph to figure out the hypotenuse, right? So check this out. I want this to be a little right triangle like this, but since it's not at standard position, I can't just look at the ordered pairs, right? So I need to figure out, hey, what's the distance between here? What's my x value essentially? And then what's the different distance between there and my y value, or vertical component? So since we're not at standard position, and I know you may not have graph paper, so you can't count the squares like I can here, we're going to use the distance formula. So let me remind you what the distance formula is. it is, let's just do, I'm just going to say distance. Well, no, let's not do that. We'll say if this is A, this is B, this is C. So just like a regular right triangle. So I'm going to say C equals, it is just like the Pythagorean theorem, right? So I know that C squared equals A squared plus B squared, right? So I need to figure out A, which I'm going to call this one down here. So that means I need to figure out what's the distance between -3 all the way over to +6. So I'm going to say -3 minus 6. That will tell me the distance between there, right? And then squared plus b, which is this. So I need to find out the vertical distance between +4 and +7. So that's going to be 4 take away 7 squared. And since this is squared right here, but this is just c right here, I'm going to take the square root of all of that. So if you don't remember this, let me go ahead and write it down here at the bottom so you can just so you have it in your back pocket, like the official formula. So the distance for this, sorry, my nose is super itchy right now. The distance formula is C equals, oh shuckles, x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared, and then you take the square root of all of that. And this is for 2 points, A equals x1, y1, and b equals x2, y2. So that's the distance formula if you don't remember it. So I just plugged in the actual numbers for it. So y'all, let's dive in and do some math. So c is equal to the square root, -3 take away 6 is -9, squared 4 take away 7 is -3 squared. So that's going to be rad 81 plus 9. So c is equal to rad 90. So that's our distance. Done. So I can say very confidently that the magnitude of AB is rad 90. Okay, perf. All right, now we need to find the direction angle. And this is going to be, now that we know the lengths of these, because we just found those right here, the length there is 9. So from here to here is 9. And then from here to here is 3. Now that we know the length of those, we can just use our tangent again. Because remember, we want to assume that this is at standard position. But since it's not at standard position, I just have to do the math with where it is up on the coordinate plane and just say, oh, okay, I'm just going to pretend like this is the x-axis right here. So I'm trying to find that angle, right? I'm trying to find that angle relative to the horizontal axis. So again, I have B is the opposite side and A is the adjacent side. So opposite and adjacent, that is going to be tangent. So I know the tangent of theta equals the opposite side, which is B, and we figured out the distance between B is 3, and I'm going to go ahead and use a +3 here, because I'm treating this just like a regular right triangle. And then the distance down here, A, we found that to be 9. And you can reduce that to 1/3 if you'd like, y'all. It doesn't really matter because we're going to type it right into our calculator. So to find theta tots. Oh my God, theta tots. Y'all, that's going to be a new food cart. Theta tots, like from mathematics. Oh my gosh. You heard it here first. If it happens, you heard it here first. I should trademark that right now. Theta tots. Okay. I'm going to do the inverse tan of 3/9. That will equal theta. Theta tots. Oh my gosh. Y'all. I still got it. All right, and that says 18.43 degrees. And let me just go make sure that that's going to be a positive. That is, because I'm lifting up. So I can say, hey, my direction angle is 18.43 degrees. I think I've been using equal signs there. Remember the degree symbol at the end there. Don't forget that. That's a big deal. Okay. y'all, so that's how you do the direction and magnitude of a vector not at standard position. And that, I think, is the end of my note. Let me just make sure that I jotted everything down that I wanted to. I believe that I did. Until next time. All right, y'all, so you should be getting a Go Formative assignment here pretty soon. And since we kind of got thrown off our A days and B days, we are a little askew, but that's all right. So we'll have today, and then we'll have one more day of vectors where we're talking about vector operations, about adding vectors, subtracting vectors, and multiplying vectors, which is very, very exciting. So that's coming up next time. Until then, be well, stay safe, do some math. Hit me up if you're having any issues or need any questions or need any answers, sorry. And I will do my best to help you. All right, guys, I'll see ya.